Hello, good afternoon. Thank you for coming to this demonstration session. My name is Francis Kim. I'm a systems engineer with DATRIUM. Our booth is right over there. After the session, we will have a drawing to give away a set of AirPods. I have a product demonstration that's queued up. It doesn't take very long, so before I dive into the demonstration portion of the presentation, I'd like to give you an overview of DATRIUM, what our product is all about, and so I'm just going to go over just a few slides. At DATRIUM, we're setting out to really transform IT to enable it to deliver instant outcomes to their businesses and in turn to the marketplace as a whole. Because let's face it, we're living in an instant economy today where everything has to be delivered at the snap of a finger. Otherwise, people will move on to the next available vendor. So in order to do that, businesses have to be able to live in and among multiple cloud environments. We believe that in order to do that, you need two key things. One is a consistent virtualization plane where you learn your virtualization skill in one place, then you can apply the same skill whatever cloud that you're moving on to. The second thing that we need is that the data that you have in your say your private cloud has to be also consistent when you move it to a public cloud or among the different public clouds, so that as you're moving your workload from place to place, from on-prem to public cloud B and C, that you're not spending a lot of time rehydrating data, reformatting, incurring all the additional risks that go with that. But we know that we have a problem with that because today, this slide describes a typical enterprise where in the middle you have the data that your company needs, and there are 5 essential functions that today are provided by 5 different products that don't necessarily work well with each other. But even if you manage to get them to work well together, now what are you going to do when you need to move those workloads to another place, a secondary site, let alone up to a public cloud? We know that's a problem. Now, let's say many of you have a cloud-first approach. So let's say you've deployed in AWS Cloud, taking advantage of its many services that are very similar to what an on-prem service would look like. Now what do you do when you need to move from AWS to Azure or Google? Is that going to be easy? Maybe not. So what DATRIUM is setting out to do is it's taking these 5 essential functions, the primary storage, backup, DR, encryption, orchestration for DR, workload mobility. We have converged all those 5 essential functions into a single platform, all delivered by DATRIUM. So there's no more cobbling together of third-party products, hoping that they'll all work together well and that you have to manage separately. So by converging these functions into one platform in what we call the Automatrix platform, you achieve really 3 things. You've simplified your infrastructure greatly because rather than 5 different products, you have a single product. You've now made it much more portable because when you want to move your workload that is running on this platform from place to place, you're taking with you all the tools that you will need, such as backup and all the other things with you. And finally, your experience in dealing with the platform is going to be the same whether you run it on-prem or at a public cloud, say AWS, or in the future in Azure or Google. You don't have to relearn something new. And so today, we call the Automatrix. It runs on your on-prem, and then you can also run it on AWS. We can replicate it out to AWS. And what I will show in a few minutes is the ability to fail over your workload from your on-prem to AWS cloud, and essentially perform a DR functionality. In the future, we plan to go to Azure as well, because as you know, VMware has announced that they're going to Azure. So essentially, wherever VMware decides to go, we will follow. And so next on our list will be to go to Azure, and then eventually to Google Cloud. Okay. And so our product set really consists of what we call the DVX, which is our on-prem instance. It's a VMware infrastructure. Obviously, it can be replicated to a second site. Then we can replicate the data to AWS Cloud, which was called a Cloud DVX. And once you've done that, then this service SaaS offering that we're providing called Control Shift will automate the DR orchestration among these different instances of your infrastructure. So at this point, what I'm going to do is actually start the demo. Okay. So on this leftmost tab is my production vCenter, on which we have a few VMs. These are the VMs that are going to be failed over to AWS Cloud. On the right-hand side, I have a vCenter that's up in AWS. At this point, there are no VMs on there that are running. And this is the interface for the Control Shift tool, which is the DR orchestration tool. This tool is for not only automating the creation of your runbook for DR, but also it is designed for running continuous compliance on your runbook to make sure that your production and your DR environments are consistent with regard to their infrastructure, such as the VM networks, the data stores, vCenters, can they be reached at all times? And this is a test that is performed every half hour. I'm going to show you that you can create these multiple runbooks for different purposes. You may not want to fail over all your work set at one time. You may only want to fail over some subset of your workload. In our demo purposes, I'm going to take this particular plan called offsite access, in which we will take workload from a QA data vCenter up to a Cloud DVX instance in AWS. This happens to be in the Ohio region. Before I actually run the orchestration, which doesn't take very long, I'm going to walk you through kind of the process by which we develop this runbook. And you can see on the left-hand side, on the navigation pane, that we have these areas of concern that any sort of DR runbook development would have to consider, such as, from what site to what site are we doing the failover? Which groups of VMs are we going to fail over? What are the vCenter mappings? So on and so forth. So in this case, we're taking what we call a protected site, our headquarters, and we're going to fail it over into AWS instance of our data, which is the Cloud DVX. We're going to be leveraging the VMware Cloud, the SEDC, to bring up the workload. Okay. And there are different types of failovers that can be done. In the interest of time, I'm going to just do the abbreviated failover. Here we decide, well, which groups are going to be failing over. Like I said, you can select all of them or some subset of the work set. This is where you do the mapping between the source, the production side vCenter, to the target side vCenter for disaster recovery. And likewise, for vCenter folder mapping from source to destination. What compute resources are we going to use as we fail over to the DR site? Which virtual networks are going to be mapped to which final destination networks? And of course, any IP address mapping that needs to be done when you're doing the failover. Because in all likelihood, on your destination side, on your DR side, your address mapping will be most likely different. And do you need to run any pre and post process scripts as you're doing the failover to make sure that there are other, if there are other facility related checks that you need to perform? And finally, what are the groups of tasks that will be performed as part of this DR? And at this point, you can add additional steps as you see fit. So you can see by going through this wizard-driven tool, you're going to be developing this whole runbook for failing over a set of workloads from one site to another. Lastly, upon different kinds of events that triggers, how do you want to be notified? Via email, to a certain address, so on and so forth. Okay. So that is the process of crafting the runbook. Now let's get to the meat of it and actually run the test, and let's see what happens. Here, you can use, by default, the latest snapshot that's available, or you can go back through and grab an earlier snapshot. And this is particularly important in the case where you suffer a site outage as a result of, say, ransomware attack, where more and more frequently these ransomware attacks have built into them an incubation period of 60, 90 days or so. The whole purpose of which is to have your local backup safe sets expire so that you're forced to restore from older safe sets, thus requiring a lot more time. And so by extending the ability to recover from a very old snapshot, you can still perform your recovery in a timely manner. In this case, for the demo, I'm just going to use the latest. And I'm going to recover into Cloud DVX, stop on every error or ignore all error and just go forward. And what this recovery is going to do is going to recover 4 of those VMs from the engineering protection group. And this is the final, are you sure moment. At this point, I'm going to rearrange my tab a little bit so you can better see, even in this limited real estate, what is going to happen. So on the right-hand side, of the screen, we have the vCenter up in AWS VMware Cloud. As you can see, it looks just almost exactly the same as an on-prem vCenter vSphere environment. And that goes to our original premise of keeping the virtualization plane as consistent as possible between on-prem and public cloud. I'm going to go ahead and pull the trigger. And while this is doing it, keep an eye on the task that it's performing on the left-hand side, but also glance over on the right-hand side to see the tasks on the vSphere side that pop up. So those 4 VMs are being recovered. Now, obviously, the data is already has already been replicated to AWS. We're not moving the data at the time of the recovery. But what the control shift tool is doing is registering the VMs and instantiating them into vCenter. And the whole, really the value of control shift, they're really, I guess, twofold, maybe threefold. One is that it helps you develop your runbook, and it encapsulates the process into a predictable framework, so that when it comes time when you have to actually perform a recovery, that you have full confidence that it's going to work. The second thing that it does is that, like I said earlier, okay, so the test failover just finished. At this point, we're going to do a cleanup, which will basically tear down the VMs that it is recovered and in AWS. And the reason that I bring that up is that once the DR, so when you're doing the DR, you actually spin up the compute resources up in AWS, which we all know is an expensive resource. So once the DR is done, then by cleaning it all up, you tear it all back down, and you can shut down the EC2 instances up in AWS, and you can stop paying the costly hourly fees. And at the end of the cleanup, and that recovery process, admittedly, it involved just 4 VMs, but it took just over a minute to perform the recovery. And at the end of the test, as we see here, you can actually create a PDF report of the tasks that were performed. So when the auditor comes by, wants to know, what was the result of your DR test, this is a document that you can hand to them. They can see for themselves exactly what was done, all the minute steps, how the resources were mapped from the production to the DR site, and so on and so forth. The other important thing is that the compliance test, which happens every 30 minutes, it generates its own report so that you always know, and you'll be notified by email, so that every day, all day long, you can get email notices of, hey, you're still in compliance, no problem, no worries, so that when a disaster does strike, you're ready to do the recovery. So that concludes my control shift demonstration. If you have any questions, please come by our booth, and there are several people standing by to answer your questions. Thank you very much.